Good day to you all. I'm Vidurapriya, and today I'm going to talk on the topic a review of the empirical correlations of peaty and organic soils in Sri Lanka. Let's first have a look at what is an organic soil. Organic soils are formed by the accumulation of fully or partially decomposed organic matter under anaerobic conditions. These soils generally accumulate in low-lying grounds with abundance of water, such as marshy lands and swamps. Engineers around the world consider peat deposits as problematic soils due to the reasons such as high compressibility, low shear strength, localized sinking, and slip failure. If we look at the factors that affect the properties of peat, we can see that the climatic condition of the accumulating area, degree of humidification, mineral proportion comprising plant, and the groundwater chemistry can be considered as the main factors that affect its properties. Roughly 5 to 8% of the world's surface are covered by organic soil deposits. Mainly, we can see most of the peat deposits can be found in the temperate regions closer to the northern hemisphere. If we consider the properties between the temperate region peat deposits and the peat deposits in the tropical regions, we can see there are differences in the properties. Even if we consider the peat deposits in the high altitude locations and low altitude locations in the tropical region, we can still see differences between its properties. Now let's have a look at the peat deposits in Sri Lanka. The Sri Lankan peat is a good example for a very low organic content soil. Generally, its organic contents are less than 75%. Peat deposits are mainly found in the western and the southern provinces along the flood valleys of the main rivers such as Kalani, Kalu, Benthara, and Nilwala rivers. If we consider the expressway extent, including the Colombo-Katnayake Expressway, Outer Circular Highway, and the Southern Expressway, most of the sections of these expressways pass through such peat deposits. As I mentioned earlier, it is important to determine the engineering properties of peat deposits before we commence construction. But the determination of engineering properties can be especially difficult due to the difficulty of sampling and maintenance of the extracted sample under the atmospheric conditions. However, the index soil parameters are comparatively easier to determine. Therefore, if we have correlations between index soil parameters and engineering properties, we can minimize the need to have expensive ground investigation procedures. If we look at the Sri Lankan empirical correlations, Karunawardana, Thevasudhan, and Thilakasiri and Ariyaratna et al. Presented early correlations for Sri Lankan deposits. In the present study, these data were divided into two main groups. First one is the Colombo deposit, which comprises of the properties of samples that were extracted along the flood valleys of Kalani River. And the second group is the Southern deposit, which comprises of properties of samples that were extracted along the flood valleys of Kalu, Benthota, Gin, and Nilwala rivers. The two different correlations for these two deposits were compared with each other to observe if there are any variations. Now we'll have look at these comparison of correlations. First, we'll see the correlations for index soil properties, starting with initial void ratio and the organic content. If we have a look at the relationship between void ratio and the organic content, we can see for a given organic content, Colombo peat has a higher void ratio. That means the Colombo peat deposits are more porous than the southern deposits. Reasons can be identified as the degree of differences in the degree of decomposition and the differences in the composition of organic matter. As there is a proportion of void ratio that from the mineral portion of the soil, we can expect to have such a scatter of data. Next correlation is the correlation between natural water content and the organic content. Here also, if we consider a given organic content, we can see that the natural moisture content for the Colombo deposits are higher than that for the southern deposits. As we previously observed that for a given organic content, the Colombo soil has a higher void ratio. Thus, it is obvious that we can expect to have a higher natural water content when compared to the southern deposits when we are comparing a given organic content. However, the natural water content of a soil depends mainly on the water retaining ability of the comprising organic matter and the degree of decomposition. Therefore, unless these samples that we are considering are in a very narrow range of decomposition, we can expect to have a higher scatter as we are seeing in this diagram. Next, we'll have a look at the correlations for engineering soil parameters. We'll start with the correlation between compression index and the initial void ratio. If we consider a given initial void ratio, we can see that we see a higher compression index for the southern deposits. To explain this, let's have a look at figure 3 again. For a given void ratio, we can see that we have a higher organic content for the southern deposits. In the literature, they mention that if a soil has a higher organic content than the other soil, that soil is very compressive when compared to the soil with a low organic content. Therefore, we can see for a given organic content that the southern peat is having a higher CC value due to its high organic content than that of the Colombo peat. The next correlation is the correlation between compression index and the natural water content. If we have a look at a given natural content, we can see that the compression index for southern deposits is higher than that for Colombo deposits. We'll have a look at the figure 4 again. Here also we can see for a given water content that the southern soils has a higher organic content. Thus, as I explained earlier, as the southern deposits has higher organic content when comparing a given natural water content, that soil has a higher compression index. The next correlation is the correlation between the compression index and the organic content. If we consider a given organic content, we can see that the Colombo soils are more compressive and has a higher CC value. To explain this, we'll have a look at figures 3 and 4 again. For a given organic content, we can see that the Colombo deposits has a higher void ratio. And even for a given organic content, the Colombo soils has the highest water content. Thus, it is natural to expect a higher CC value for a soil with the highest void ratio and the water content. In contrast to the above discussed correlations, we can see there are some correlations that does not show any differences in behavior depending on the morphology. One example is the correlation between the compression index and the secondary compression index. Here, it is believed that the secondary compression index of a soil depends only on the compressibility of the comprising matter. So it is safe to assume that Sri Lankan deposits, either Colombo or Southern, have similar compressibility. Thus, we are seeing similar correlations between these two parameters. The next parameter is the recompression index. The next correlation is the recompression index and the compression index. Here also, we don't see much difference between the two correlations derived for the two deposits. It is evident that it is believed that this correlation between recompression index and the compression index only depend on the type and the way of testing, not with the morphology. To conclude the matter, let's recall that we observed variations between most correlations derived from the Colombo deposits and the southern deposits, and the reasons were discussed. Thus, we can establish that the fact that there are morphological differences between the Colombo peat deposits and the southern peat deposits, which resulted in the above variations. However, it should be kept in mind that these correlations were derived based only on a limited amount of data. Therefore, to further solidify these observations and to strongly conclude the morphological differences between the two deposits, necessary targeted investigation should be carried out, especially tests such as microstructure analysis. Also, we observed that the correlations between compression index and recompression index, compression index and secondary compression index did not show any variation based on the differences in the morphology. Thank you.